draw the BMD and SFD, bending moment diagram and shear force diagram for the beam shown in figure below. So the main difference or new thing in this numerical is you can see a crank here, which is a L-shaped crank of 1 meter by 1 meter length, and a force of 10 kilonewton is applied at the end of this crank here in the downward direction. Now when you have numerical like this, then how to solve the BMD and SFT? So it's very simple. Now this 10 kilonewton force that is acting at the end of the crank, I will have to convert into a point load and a couple which is acting at point B, and then we will have to redraw the load diagram first. So that is the starting point of the numerical. So what will be the magnitude of that point load and the couple that is acting at B? Now if you see, this force is acting in downward direction. So I have made another load diagram just below this so that I don't have to make the dimensions again. So at point B, if you see, I have taken this 10 kilonewton force which is acting here. I have assumed that to be acting at this point. Now along with this, I need to add a couple. Now what will be the couple? The magnitude of the couple is, you see, couple is force into perpendicular distance. Now this is a vertical force, so I will take the horizontal distance like this. So from B, this force is at 1 meter distance. So the magnitude of couple is this force into this distance. So that is 10 into 1, that will be 10 kilonewton meter. Now the direction of the couple, so this is acting in downward direction. So about point B, this will make a clockwise couple like this, right? So I will show a clockwise couple here. This, and I need to show an arrow. So I will just make an arrow like this, right? So this is a clockwise couple which is acting at point B, and the magnitude of this couple is 10 kilonewton meter, right? Now we can solve this numerical because this is similar to the numerical what we have solved earlier. Now let us start the solution. So the first thing I need to find uh, solution, support reaction. Okay, for finding the support reaction, I have two conditions: sum of all the forces equal to 0, sum of all the moments equal to 0. Now let me take first moment about point 1. Taking moment about point A. Sorry. Point A. Now for this, I need the sign convention. Let me first make the sign convention. So I will draw a rectangle like this. Make this into a table of 4 cells. then this will be left side, this is right side, this is clockwise, and this will be counterclockwise. Okay, so left side clockwise is positive, right side counterclockwise will be positive, left side counterclockwise will be negative, right side clockwise will be negative. Right, so this is the sign convention we are following. Okay, some students were asking, should we follow the same sign convention or what? See, there is nothing like this. This is the common sign convention which everyone follows. If you use it in otherwise, let us say right side clockwise if I take positive and left side counterclockwise if I take positive. The reverse sign of this, the bending moment diagram that you get will be a mirror image, right? There is nothing wrong in taking different signs. You will get a mirror image of the bending, but I would suggest you follow the same sign convention. Okay, now let us take the moments about point A. So I'll start from this edge. So here I do not have any point load. Okay, so I'll come to the next point, that is B. This is vertical upward force. I have the reaction here. I'm assuming it in upward direction, and this is making a clockwise movement about point A. So right side, sorry, it is counterclockwise. So right side counterclockwise is positive. So I will write like this: RD into the perpendicular distance is 6 meter. 2 plus 2 plus 2, 6. Um, then I have a UDL here. Now this force is acting downwards. So downward force, it will make a clockwise couple on the right side of the section. Right side clockwise is negative. So minus the magnitude or the intensity of the force is 3 kilonewton into the length, which is 2 plus 2, 4 meter. Now I assume that this 4 meter UDL, the center of gravity is here, midpoint. So the perpendicular distance will be 2 plus 2 plus 2, 6 into 6, right? Then come to this point C, there is no force. Come to point B, I have a vertical force of 10 kilonewton. So since it is downward, it will also create a clockwise moment on the right side, which will be negative. So minus 10 into perpendicular distance is 2 meters into 2. And I have a counterclockwise moment, right? Sorry, this is also clockwise couple, which is acting at point B on the right side. So right side clockwise is again negative. So I will take that as minus 10. And all these things together should be equal to 0. Now if you solve this, you will get RD. So let me start my calc. Okay. So all these are negative, so it will go on the other side as positive. 3 into 4 into 6 plus 10 into 2 is 20 plus 10. So this is 102 divided by 6. So that will be 17 kilonewton. So RD is equal to 1717 kilonewton. Now sum of all the forces equal to 0. on the beam for equilibrium. Now I will take upward forces in one direction, one side, and downward forces on the other direction, or you can put it like this also. I'll better put it like this. RA plus another upward forces at D. So RD minus all the downward forces. At point B, I have 10 kilonewton minus between C and D, I have uniformly distributed load of intensity 3 kilonewton and the span is 4 meter. So 3 into 4. For calculation of shear force and whenever you are considering the forces, the couple is not included. So don't put this couple in this equation, and this should be equal to 0, right? Now if you solve this, you will get the RA, right? So this negative will come on the other side as positive. So 10 plus 3 fours are 12, 22 minus RD, that is minus 17. So RA is equal to 5 kilo Newton. Okay, so this is the reaction at point A and B. Okay, now we have to start with the shear force diagrams. So for drawing the shear force diagram, let me just write shear force diagram. I will start with point A. Always start from the left side so that it is easy. So SFA LHS is equal to 0. SFA RHS. I'm just taking that section on the left side of that section and right side of section, right? RHS is equal to RA, the force, reaction force that is acting there, that is 5 kilo Newton. Positive force, so it is upward direction. Now between A and B there are no force, so it will remain constant. So SFB on LHS will be equal to 5 kilo Newton. SFB RHS is equal to, now I have 5 kilonewton here, right? At this point I have 5 kilonewton. There is a 10 kilonewton force which is acting downwards. So 5 minus 10, and that is equal to minus 5 kilo Newton, right? Let me parallel it right also here. So I forgot this. RA is equal to 5 kilonewton and RD is equal to 17 kilonewton, right? Now for drawing the shear force diagram, what I will do is I will first draw a line like this. So this is my zero shear force line. Now from at point A, it will start with 0. So this is 0. That is SFA LHS. Then at SFA RHS is 5 kilonewton. So I will draw a line like this. So this is representing 5 kilonewton. And between A and B there is no force, so it will remain constant like this. And at B, it is 10 kilonewton force which is acting in downward direction. So it becomes minus 5. So the shear force varies from plus 5 to minus 5. It will come down like this. Okay. Then between point B and C, this is C, there are no force. So SFC, it will remain same, right, on LHS and RHS. So I will not say LHS RHS, I will just write SFC is equal to minus 5 kilo Newton. So I'll just draw that. Okay. Now from C to D there is a UDL, right? Because I have another point first. If I didn't have this reaction, I could have considered the entire UDL. But now since I have a reaction here, so the shape will be different. So from C to D, I have a UDL of 3 kilonewton per meter. So let me first find the shear force at point D. Now what will happen at D? SFD on LHS from the left hand side. Now I am already at minus 5 kilonewton. I have to subtract this force, that is 3 kilonewton into 2 meter. So 3 into 2. So let me open my calculator. Minus 5 minus 3 into 2. So it will be minus 11 kilo Newton. So this is on the left hand side. SFD RHS is minus 11. Always start with the previous value. Whatever value is, if you see from everywhere I have done that only. Now here it is 0, here it is 0 plus 5. It is 5 here, 5 plus 0. Then here 5 minus 10. So that is minus 5. So the same minus 5 has come here. There is no change, plus 0. And minus 5 minus 6 minus 11. Now I am at this point minus 11 and there is a upward force of 17 kilonewton. So that will be positive plus 70, right? So this will be 6 kilo Newton. Now let me first draw that. So I have to go down by 6. This is 5. Let us say this is 11. Now from here I have to go up by 17. Let us say this is 17 or plus 6 kilonewton. So at point D, you have shear force varying between 6 to minus 11 kilonewton, right? So this is the variation. I just decrease this point because it is 6. This is 5, so let this be 6. Now again, let us come back here. It is the last point, that is E. Now between D and E there is only this UDL, right? So SF E, there will be no left hand side right hand side there because it is going to become 0. So that is equal to, take this value 6 minus the intensity of the force is 3, UDL is 3, and the length is 2. 3 into 2 is 6, so this will become 0. So I have to just join this point to this point, right? Now just write all the values here. So this is 0, it is starting from 0. This is 5 kilonewton, right? And I get both the points. Here also it is 5 kilonewton, and here it is how much? Minus 5. This is again 5 kilonewton. See, in the SFD and BMD, for the SF and BM that you are marking, do not give the sign, because here I am going to show the sign. So this is also 5 kilonewton. This is 11 kilonewton. This is 6 kilo. Okay, and this is positive. This is also positive. This is negative. Okay, so this is the shear force diagram. Now we will have to draw the bending moment diagram for this. Okay, for drawing the bending moment diagram, let me first let us calculate the moment. Now if you see here, the shear force is not suddenly changing from positive to negative, right? So I have a sharp change. So if you have like this, then you don't have to find the point of maximum bending moment. Only when you have a sudden change in the sign, then you have to do it. Okay, bending moment diagram. Okay, now I have to find the bending moments. Uh, BMA is equal to 0, reason and support, right? So if you have a support in the end, then you will have the bending moment equal to 0. Now let me go to the next point, that is point number B. Now BMB is equal to, now at B I have a couple like this. So whenever you have a couple, you will have a sharp change in the bending moment. So for this reason, at such section you have to find bending moment considering the forces on the left hand side and right hand side both. So left hand side bending moment is equal to, now this is the left hand side, right? So this is making a counterclockwise moment on the left hand side, sorry, clockwise moment on the left hand side, so that will be positive 5 into perpendicular distances 2, and I don't have any other force there, correct? So that will be equal to 10 kilonewton meter. Now considering the right hand side, BN B RHS. Okay, now let me start with this. So this is upward, so that will make a positive moment. 17 into perpendicular distance I'm taking at B, so this will be 4. So into 4, right? And I have this UDL which is acting downwards, so that will be minus 3 into length is, this is 2 meter and this is 2 meter, so it is 4 meter, and I am assuming it acting at the midpoint here. So into 4 by 2, or let's write 2. There is nothing more than that, because this force is acting on that point itself and this moment is also acting on that point. So I'm not considering both of these, right? So this is equal to 17 into 4 minus 3 into 4 into 2. That is 44 kilonewton meter. Alright. Now let us go to point C. Now all other points it will be only one bending moment, so you don't have to worry. So BMC is equal to, this is the point. So let us take left side, because here I have UDL. Or this is also simple. I'll take right side only. So this will be 17 into 2 minus 3 into 4. Wait a minute. I think I made a mistake here. Yes. See, this is what I did. I made a mistake in this. BM, I'd be on the right hand side. Sorry?
So in place of 2, there will it's a 2, 4 हवा है का?
Yes, yes. That's what I'm trying to say again. See, this UDL is 3 kilonewton per meter. So the force is 3 into 4, 12 kilonewton, and that will be acting here. So this distance is 4. I put it as 2. I'm correcting that. So this will change. Look that I saw now. 17 into 4 minus 3 into 16. So that will be 20, not 44. 20 kilonewton meter. Okay. Now I'm come to point C here, right? So here this distance will be 2. This force is here. 3 into 4 is at this point. This point to this point it is 2 meter. So into 2. So 17 into 2 minus 3 into 4 into 4 into 2. That is again 10 kilonewton meter. Right? I come to C and come to D. B and D is equal to, I'll take the right side because I have only this UDL, nothing else is there. Left side you have so many forces. So this force is acting in downward direction. So it will be negative, correct? So it will be minus 3 into, the length is 2 meter and it will be acting at the midpoint here. So that is 1. So into 1. So this is minus 6 kilonewton meter. So since the BMD sign is changing, I will have point of contra fracture. I will have to find that, right? So BMD is done, and BME is equal to 0 because free end. Whenever you have a free end or support, the bending moment is equal to 0. Okay, so I have calculated all the bending moment. Now I have to draw the BMD, right? So for drawing BMD, let me see the values. The maximum on the positive side is 20, and on the negative side it is minus 6, right? So I think this much space is enough. If you have graph papers, it would be easier for drawing the BMD SFT, because you don't have to sit and measure approximately. You can quickly draw it. Now let us start from A. At point A it is 0, so it will be this only, 0 here. Then at B, left hand side is 10 and right hand side is 20. So I will just draw two lines here. Let us say this is 10. 20 is the maximum, right? So let me take this as 20. So this will be 10. I'm just making approximate marking here. Uh, Now there is no load between A to B, so you just have to join the ends. So at A it is 0 and at B it is 10. Now because of this couple, the load is the bending moment is increasing suddenly here like this. Okay, now let us come to point C. At point C it is 10 kilonewton meter. So 10 is here. I will just draw a line from here to here like this. Okay, it's a straight line. Now from point C to D, right? Uh, at D it is minus 6. So it will be on the negative side here. So this much I have taken 10. So let me take this as minus 6. I'll take this as minus 6. Now from here to here, it should be a parabolic curve, right? Because it is UDL, it will be a parabolic curve. So I'll just draw a curve here. Right? It should be a curve like this, and you just write here it is parabolic. That is enough. You don't have to sit and do research on this. And at E it is again 0. So this will also be parabolic curve because this is a UDL, right? You'll have a curve like this. So this is your bending moment diagram. Now let us just write down all the values. So this is 0. This is 10 kilonewton meter. And this is 20 kilonewton meter. Again at this point this is 10 kilonewton meter. This is minus 6, sorry, just write 6 kilonewton meter, and this is 0, right? This point is 0. Now this is positive, this is negative, right? This is the BMD. At this point, the sign of bending moment is changing suddenly, right? And the value of the bending moment at this point is equal to 0. Now this point is called as point of contraflexure, right? So we have to find the point of contraflexure. Now how to find this point? Anyone remembers? Yes?
Distance, assume distance at x and then moment लेना होगा.
Yes. So see, I know that the point is on the left side of D and it is between C and D. Correct? If you see here, this is D, this is C. So it is on the left side of D between C and D. So I will draw a section here. I'll first draw a line like this, right? I'll call this length as X. This uh, length is X, and the bending moment at this point is 0. I know it from the bending moment diagram, right? So BM at A, B, C, D, E, let me call this point as F. So BM at point F is equal to 0, and using from that I will have to calculate the, okay, the session is going to end. I'll just write the formula here. You can calculate this. So Bm at F is equal to, I'm considering the right side. So I have vertical force. So that will be positive 17 into the distance is this much, right? So it will be x minus this length, that is 2. That is the perpendicular distance of RD, and because of this UDL it is downward force, so it will be minus 3. I'll not put into here because x and into it will get confused. So 17 into x minus 2 minus 3 uh, into the length of UDL itself is x, into the distance from which the force is acting, that is x by 2. So I will write it as x square by 2, right? And this should be equal to 0. Now if you solve this, you will get the value of x, that is the point of contraflexure, right? So we will stop at this point because my meeting is about to end now. Is there any question?